Number 14, find the amount of time required for an investment to double at a rate of 5.2% if the interest is compounded continuously. So we need to create an equation for this. And we're going to first focus on that part that says it's compounded continuously, because that tells us that we're going to use this equation. The ending amount, or the amount in the account at some given time, is equal to the principal, what you put in there initially, times e to the rate times time. All right, and so we want this to double. So we want whatever we put in for p, we want to double that. And so a is going to be twice what p is. And then we'll solve for t. That's going to be how we solve this problem. Now, as long as we get to, it doesn't matter, it doesn't tell us what we put in there initially. All it tells us is we want the amount to double. So let's go ahead and just put in $1 for our principal, which would make the amount at the end worth $2. So 2 is going to be equal to 1p. So we'll just, p is 1, so we'll just leave it off. It's equal to e to the rate, which is 0.052 times time, which we don't know. That's what we're trying to solve for. All right, so now the variable that we're trying to solve for, t, is up here in the exponent, which means that we're going to need a log to solve for that. So, and the base of this exponential term here is e, so we're going to need a natural log base e. So let's take the natural log of both sides. Natural log of 2 is equal to the natural log of e to the 0.052 t. And the reason we did that now is that the natural log of e, those are going to cancel each other out, and we're just going to be left with the exponent, which is 0.052 t. So the natural log of 2 is equal to 0.052 t. And then to solve for t, divide both sides by 0.052. And we plug that into a calculator. We get the natural log of 2 divided by 0.052 gives us 13. T is going to be equal to 13.3298. So about 13.3 years is how long it's going to take for our money to double.